Welcome back to the FAQ Shack. This is the show where we dive headfirst into the science behind all those questions you've probably wondered about. And this week, we are tackling a really colorful mystery, one that happens right on our own skin. And we're doing it all because one of you asked. Alex from Ohio, thank you so much for sending this in. What a great question. And you know what? You absolutely nailed it. It's not random at all. There is some seriously cool science behind it, and it tells this amazing story about how incredible your body is at cleaning up and healing itself. So let's dive right in. I mean, we've all been there, right? You bump your leg on the coffee table, you take a little tumble, and a few hours later, bam, you've got this colorful splotch on your skin. But have you ever stopped to think about what that mark really is? And why does it put on this whole color-changing show before it finally disappears? It's like a tiny personal light show. All right, so before we get to the really cool chemistry part, the color-changing rainbow, we got to get our terms straight first, because it turns out not all bruises are created equal. Okay, on the screen, you're seeing two terms, ecchymosis and hematoma. Now, for what we're talking about today, we're focused on ecchymosis. It's a fancy word, I know, but it's just the scientific name for that typical flat bruise you get from a minor bump. A hematoma, though, that's a different beast. It's a raised, swollen area, a much bigger pool of clotted blood, kind of like the difference between spilling a little bit of water and having a huge puddle. And a hematoma can be more serious, so it's good to know the difference. All right, now for the main event. Let's get right to the core of Alex's question, that wild color show. This is no accident, folks. It's a very specific chemical story, a biological timeline that your body follows every single time. So here it is, the whole life cycle laid out. Right after the injury, in those first couple of days, you get that classic red, blue, or even deep purple color. That's all the fresh blood that's just leaked out. But then, look what happens. Around day 5 to 7, it starts turning green. Weird, right? Then, a few days after that, it goes yellow or brown before it finally disappears. So, what exactly is causing those color shifts? Well, let's meet the main players. So, the first character in our story is hemoglobin. This is the protein in your red blood cells that's responsible for carrying oxygen all around your body. It's full of iron, and that's what makes blood red. When you get a bump and those tiny blood vessels break, hemoglobin spills out. As it loses its oxygen, it gets darker, and that's what gives you that initial reddish-purple or blue color. Okay, so what about that green phase? Well, after a few days, your body gets to work breaking down all that spilled hemoglobin. And the first thing it turns into is a new pigment called biliverdin. And yeah, the name kind of gives it away. It literally comes from the Latin for green bile. This is the stuff that gives your healing bruise that distinct green color. It's actually a really good sign. It means the cleanup is officially on. And for the final act in this Technicolor drama, we have bilirubin. Your body takes that green biliverdin and breaks it down one more time, creating this yellow pigment. That's what causes that final yellow or brownish stage you see just before the bruise completely disappears. It's the last stop on the journey. The recycling is almost complete. But wait a minute, this chemical transformation from red to green to yellow, it doesn't just happen by magic. Oh no, your body actually sends in a microscopic cleanup crew, a team of first responders working 24/7 to deal with the damage. So who are these tiny workers? Well, think about it. The moment you get that injury and the blood vessels break, it's like an emergency alarm goes off inside your body, and your immune system doesn't waste a second. It immediately dispatches these specialized cells to get to the scene and manage the crisis. Let's break down that response. First, you got the vessel rupture. Almost immediately, within hours, the first wave arrives, neutrophils. Think of them as the first cops on the scene, setting up the yellow tape and doing crowd control. But then the real cleanup crew arrives, the macrophages. These guys are the heavy-duty sanitation workers. They literally come in and eat the spilled blood cells and all the other debris. And get this. The entire color-changing process we just talked about, it happens inside these macrophage cells. They are the true MVPs of the whole operation. You know, we absolutely love getting your questions. And we got one in the mailbag that ties in perfectly with what we were just talking about, this whole idea of the cleanup crew, and, well, what happens when the job is just a little too big for them? Science Fan 88, this is such a great question, and I bet a lot of you out there have wondered the same thing. You are definitely not alone. Sometimes, especially after a really nasty injury, that cleanup crew, well, they can leave a little something behind. So what is that stain? It's something called hemosiderin staining, And honestly, the best way to think about it is like a microscopic tattoo made of leftover iron. If the injury was really bad and there was a ton of blood, those macrophage cleanup cells can just get totally overwhelmed. It's like trying to clean up a massive oil spill with a single roll of paper towels. They just can't process all that iron fast enough, so some of it gets left behind, stored in this brownish, rusty compound that can literally stain your skin.
Okay, so understanding how a bruise works is cool, right? But this isn't just a fun science fact. This knowledge, understanding this exact timeline, has incredibly important real-world applications. And this is where things get really serious, especially when we talk about forensic medicine. Because sometimes the story a bruise tells is a very, very serious one.
Take a look at this number. In the U.S. alone, around 3 million suspected child abuse cases are reported every year. But tragically, only about 30% of those lead to a conviction. And a big reason for that is that evidence, especially bruises, can be really hard to interpret. And this is exactly where the science we've been talking about becomes absolutely crucial. Think about it. If you can scientifically, accurately determine the age of a bruise, you can confirm or deny an alibi, you can piece together a timeline of events. This isn't just an interesting science project. It can be the key piece of evidence that protects a vulnerable child. And that's exactly why scientists are working on new ways to do this that are far more accurate than just looking at the color. And this is how they're doing it. It's so clever. What researchers have figured out is that bruises don't just change color, they change shape. That yellow pigment, bilirubin, is a much smaller molecule than the red/blue hemoglobin. It's like the difference between sand and big rocks. The sand can spread out faster and further. So by measuring the ratio, how much yellow area there is compared to the red/blue area, they can build a model that estimates the age of the bruise with incredible accuracy. We're talking a game changer for these kinds of investigations. So let's wrap all this up. What's the big takeaway from Alex's awesome question about the story happening right there in our skin? At the end of the day, a bruise is so much more than just a splotch. It's a story. It starts with broken blood vessels. Then comes that incredible color change. The red and blue of hemoglobin gets broken down into the green of biliverdin, which then becomes the yellow of bilirubin. This whole show is managed by that amazing cellular cleanup crew, the macrophages. And yeah, sometimes they leave behind a little iron stain called hemoglobin. And most importantly, understanding this whole timeline, it's not just cool, it's vital for things like forensic science. And that really makes you think, doesn't it? If there's a story that complex and that detailed packed into a simple bruise, what other secrets is your body telling you right now? What other amazing things are happening under the surface that we just take for granted? So do you have a question that's been bugging you, something you want us to unpack? Drop it in the comments below. We're always looking for our next great question. Thanks so much for hanging out with us, and we will see you next time here at the FAQ Shack.